the definite integral when some areas are positive and some areas are negative. So we've talked about what it means for the area under the curve to be positive. Our function is above the x-axis and we're counting our areas as positive. We've talked about what it means when the area under the curve is negative. Our function is below the x-axis and therefore our rectangles have y values that are negative, and therefore we count our values as negative and our area as negative, which means that the original function is going to be increasing when the area is positive and decreasing when the area is negative. So how do we deal with functions that have areas that are both positive and negative? So if you take the integral from a to b of f of x dx, it's the sum of the areas above the x-axis, counted as positive, and the areas below the x-axis, counted as negative. So we're going to sum it up to get the cumulative change. So what that means is if you have an equal area above the x-axis as below the x-axis, then the total change will be 0 because the positive area will be added to the negative area, and if they're the same, they will cancel each other out, which means that our original function increased as much as it decreased, and it ended up at the same y value where it started. So remember, area is always going to be positive unless you are given a reason to assume otherwise. So again, if you are looking at area in a context that is not related to derivatives or area under the curve, as we have been looking at in this sense, you need to count area as positive. So let's look at an example where this will come up. Example 1. Find the total area between y equals 4 minus x squared and the x-axis for the interval 0 to 5. So here, we're looking for the area between the function and the x-axis from 0 to 5, which is this shaded area here. What I want you to notice is that nowhere in this problem does it talk about taking integrals or having a function that's a derivative. So this question is literally just about area. And that means that we need to find all the area in terms of area being positive. Now, we don't want to do this geometrically. We can use the tools we have to be able to talk about area even when we're not talking about it in a calculus sense. So if we were to take the integral from 0 to 5 of this function, it would take all of the positive area and then it would add all this negative area and it would give us a cumulative area, and that's not what we want. We don't want to know how much the original function changed. That's not what we're talking about here. Instead, we need to figure out a way how we can figure out the area from 2 to 5, and we need to count that as positive. So we can use integrals to help us out. So if we take the integral from 0 to 2, notice that 2 is where I cross through the axis. That's why I'm picking that as my point here, of 4 minus x squared dx. If I were to integrate that function, I would get 5.33. And that number comes out as positive, which I was expecting since this area is above the x-axis. Again, I chose to do the integral from 0 to 2 because that's the area that I saw that was above the x-axis. And I knew that if I computed that it wouldn't be doing any math in the background with negative numbers. Everything there would have been positive. Now, if I compute the integral from 2 to 5, I know that my calculator is going to spit this out as negative. But when I plug it all in, again, of the function 4 minus x squared, I get negative 27. I was expecting it to be negative because my calculator thinks I'm doing something in relation to calculus. So it's counting these rectangles as negative. But I know that that means that this area right here is 27. So I can use that knowledge of integrals to be able to find area for other contexts, which means that the area from 0 to 5 is going to be 5.33 plus 27. Not negative 27, because again, this is not in the context of any sort of calculus. This is just area. area between the function and the x-axis. So I count it all as positive, and when I add those together, I get 32.33. So if I'm just looking for area, I can use the definite integral to help me determine that area so that I don't have to do it geometrically. But I have to be very cautious about where the area is positive and negative and make sure that I compute my negative area separately so that I could count it as positive. If I had just integrated this function from 0 to 5, then I would have ended up with negative 21.66. And that's because it would have taken this positive area and added it to negative 27, which is not what I wanted here. I wanted the total area, which was the sum of the positive areas. So the wording here is very important. But let's look at some examples where we are going to evaluate negative and positive areas together and see how that would look.